Welcome back, students. Let's continue with the chapter 3, classification of elements and periodicity in properties. And in this chapter we are going to see the next topic, that is the division of elements into S, P, D and F blocks when they are being placed up in the periodic table. Okay, so let's see how they are being placed up in the S block, P block, D block and F blocks when they are put it out in the periodic table. So here let me draw the periodic table for you. A small replica of the periodic table I am drawing here. So your periodic table looks something like this. Your periodic table resembles something like this. So let's say this is the periodic table. Okay. This is the Moseley's periodic table. Now here in this Moseley's periodic table or modern periodic table, okay, it has been also termed as modern periodic table. The elements are divided into different blocks. Okay. So the first block is the S block. Then second block is the P block. The third block is the D block and the last block is the F block. Okay, so what are these blocks? In the previous chapter, I have told you about the S suborbital, P suborbital, D suborbital, and S suborbital, P suborbital, D suborbital, and F suborbital. Okay, so on the basis of these suborbitals only, what has done the blocks of a periodic table, the blocks of the modern periodic table is been divided out here. And what is the significance of this particular thing? Let's see here. So let's first talk about the S block elements. S block elements. What is the significance of the S block elements? So which elements are termed as the S block elements? The elements in which the elements in which valence electrons valence electrons enters the s orbital s orbital of their outermost shell of their outermost energy level, okay, of their outermost energy level are called S block elements. They are termed as S block elements. Okay, it consists of elements of group 1 and 2. Okay, here we will see that the group 1 element and group 2 elements are present as the S block elements. It means that alkali earth metals and alkaline earth metals, both these are termed as the S block elements. What are some of the general characteristics of the S block elements? Okay, so general characteristics of S block elements. Let's talk about this. Number one, they are soft metals. They are soft metals having low melting point, having low melting and boiling points. Okay, they are soft metals and they are having very low melting and boiling points. Generally, all the metals which are present in the first group, they are very soft. Okay, and the melting, due to their softness also, what happens? They are having very low melting and boiling point. They have very low ionization enthalpy. They possess very low ionization enthalpy, and due to this reason they are very highly reactive metals. Okay, they are highly reactive metals. They are very reactive due to the presence of very low ionization enthalpy. They are highly reactive. Okay, they are highly reactive in nature. Okay, and they can form univalent compounds and bivalent compounds. Okay, so the univalent compounds are termed as alkali compounds. Okay, and the metals which are forming univalent compounds, they are termed as alkali metals, while the metals which are forming bimetal compounds, they are termed as alkaline metals or alkaline compounds. Okay, because of their high reactivity, they are never found in pure state in nature. Okay, this is a fact that as they are very reactive, so the compounds of these elements will be found out, the compounds of these metals will be found out. We cannot found the them in the pure state there. They act as strong reducing agent. They act as reducing agent strong reducing agent. Most of them impart most of them impart characteristic color characteristic color to the flame when they are burnt out. Okay, they are having their characteristic flame when they are burnt out there. Okay, they form mostly the ionic compounds. We will see that they are mostly forming ionic compounds, but in some cases such as lithium and beryllium, we will see that they are forming covalent compounds also. Okay, they are forming covalent compounds also. Next, let's talk about the p block elements. P block elements. What are the p block elements? The elements which are present at the most right hand side, okay, of the periodic table, they are termed as the p block elements. And the p block elements are consisting the elements from group number 13 to group number 18. Okay, p block element are consisting elements from group 13 to group 18. Okay, they are consisting the elements from group 13 to group 18. Also, here we will see that the general electronic configuration, okay, general electronic configuration for the p block elements will start from nh2 np1, nh2 np2, nh2 np3, nh2 np3, nh2 np4, ns2 np5, and for the noble gas it is ns2 np6. These are the different general electronic configuration which we are seeing in the p block elements. Okay, and also the general electronic configuration can be written for p block element as ns2 np1 to 6. This is the general electronic configuration for your p block elements. Okay, now what are some of the general characteristics? Let's discuss about this. The general characteristics for the p block element. General characteristics for p block elements. So general characteristics for the p block elements, here we will see that they include both metals and non-metals. Okay, they are including both metals and non-metals. There is a regular graduation. There is a regular graduation, sorry, not graduation, gradation. Okay, there is a regular gradation gradation from metallic to non-metallic character. Metallic to non-metallic character here. Okay, we will find out regular gradation from metallic to non-metallic character as we are moving into period, as we are moving along period, moving along a period from left to right, from left to right. The metallic character here increases as we are going down in the group. Okay, the metallic character increases on going down in the group, on going down in. Next, their ionization enthalpy, their ionization enthalpies are relatively high as compared to S block elements. Their ionization enthalpies are high as compared to that of the S block elements. Okay, they are having very high ionization enthalpy, and due to this reason, what will happen? They will be possessing very high electronegativity. Okay, because the more the ionization enthalpy, the lower the chance of removal of electron from their outermost shell, and hence here what will happen? They will start to accept the electrons in their outermost shell, and they will show higher electronegativity. They form mostly covalent bonds. Okay, they will form mostly covalent bonds. They are having the tendency to form covalent bonds. Okay, but some of the elements can form ionic bonds also. Some of them show more than one oxidation state. Some of them shows more than one oxidation states in their compound. In their compounds, there occurs a gradation from reducing. There occurs a gradation from reducing to oxidizing agent. Okay, reducing to oxidizing property. Sorry, reducing to oxidizing property as we are moving, as we are moving across the period, across the periods of this block, across the periods of this block. Okay, so these are some of the general properties for the general characteristics of the p block elements. The elements of S and P block are collectively called representative elements. Okay, the elements of S and P blocks are collectively, they are termed as representative elements. The elements of large group 18, they are termed as noble gases, and the group 17 elements are termed as halogens, while the group 16 elements are termed as chalcogens. Okay, group 18 elements, noble gases, group 17 elements, halogens with -1 valency, group 16 elements, chalcogens. Okay, chalcogens with -2 property here. Okay, -2 oxidation state. Now let's talk about the d block elements. have a discussion about the D block elements. So the elements which has last valence electron to be filled up in to be filled up in d orbital are termed as D block elements. Are termed as D block elements. Okay, these elements are also termed as transition elements. Okay, they are also termed as called as transition elements or transition metals also. Okay, because all the elements which are present in the D block, they all are metals, so therefore they are also termed as transition metals. Okay, also their properties are somewhat in the middle of that of the P block and S block elements. Okay, we will see that their properties are somewhat in the middle of that of the S block and P block elements, therefore also they are termed as transition elements. The transition elements are generally forming a bridge between the S block and P blocks. Okay, and the groups which are included here, they are the from the elements group number 3 to group number 12 elements which are included in the D block. They all are termed as the D block elements. Okay, here we will see that the highly reactive S block elements and the less reactive group 13 and 14 metals, they are forming a bridge. Okay, they are forming a bridge here, and therefore they are termed as transition elements. The D block comprises of three complete rows of 10 elements. Okay, it is comprising of three complete rows of 10 elements, and that particular rows are termed as first transition series, second transition series, and third transition series. Three transition series are there in the transition elements, which are containing, each are containing 10 elements there. Okay, so the first series is having the elements, that is scanadium 21 to zinc 30. 10 elements are there. Next is the second transition series, where we can find yttrium. Okay, yttrium 39 to cadmium, that is 48. Next is the third transition series, that is the elements there starts from lanthanum, that is 57 to hafnium, HF. Okay, HF, it is having atomic number 70. Okay, the sixth period, that is the 5d orbitals are gradually filled out here. Okay, in the last year we will see that it is the 6d row is been filled out, 6d orbital is been filled out here, 5d orbital is been filled out, and here 3d sorry, 6d, not 60, here it will be 5d will be filled out. Sorry. Here 5D will be filled out, 4D here it will be filled out, and here 3D will be filled out here. Okay, one more series is present. Okay, one more series is there, that is fourth transition series. Fourth transition series, and in this fourth transition series from actinium, that is 89 to rutherfordium. Okay, to rutherfordium Ru, which is having atomic number 104, to copernicum co, okay, not co, yeah, copernicum, I think so it is CR, I think so. Not CR. One second. I am telling you the Copernicum. Copernicium. It is having actinium CN. Copernicium CN, and the atomic number is 112. Here is the four transition series, and here 6D is been filled out here. Okay, 6D shell is been filled out, 6D orbital is been filled out in the four transition series. What are the general characteristics for the D block elements? Let's have a look on the general characteristics for the D block elements. Okay, general characteristics. Characteristic for D block. Number one, they are metals having high melting and boiling point. High melting and boiling point. In this transition elements, we will find out some of the metals which are known as one of the toughest metals. Okay, so therefore they are having very high melting and boiling point. They possess very high melting and boiling point. Most of them are colored. The most of them formed colored compounds. Most of them forms colored compounds. They form colored compounds. 3. They have a good tendency. They have a good tendency to form complex compound. To form complex compound. Okay, what are these complex compounds? The compounds which are having coordinate bond. Okay, which are having coordinate bond. They are termed as complex compounds. Their compounds are generally paramagnetic. Their compounds are generally paramagnetic in nature. They exhibit several oxidation states. They exhibit several oxidation states. Most of the transition elements such as manganese, nickel, cobalt, chromium, platinum, vanadium are used as catalyst. They are very good catalyst. Okay, the transition elements they are used as catalyst, and they are termed as the best catalyst among all the other atoms, all the other elements. The last block is the F block elements. F block elements. The elements in which the last electron enters the f orbitals of their atom are called F block elements. They are called F block elements. Okay. In this element, the last electron is added to the to the outermost. Okay, third to the outermost. We will see that the electronic configuration for F block elements is something like this. So the F block will filled after the electron when it is filled in the in the shell, which is two shell forward to that of the S block. We will see that it is filling here. Okay, then the F block starts to fill out there. So therefore, when the elements are filled up in the F block, it means that we are filling the elements in the third outermost cell. Okay, the third outermost cell, it is been filled out here. Due to this reason, these elements are also termed as inner transition elements. Inner transition elements, they are also termed as inner transition elements. Okay, here two series are present. Here two series are present. One is the lanthanoids or lanthanides. Lanthanoids or lanthanides, two series are there, which is starting from the lanthanium, that is Z57, and the elements which are present here in the lanthanoids or lanthanium, okay, 57, the first element here is a lanthanium, and according to that name only, the name of the lanthanium only, the lanthanoids or lanthanides are given the name to this series. And the elements which are included here, they are cesium 58 to lutetium 71. Okay, these are the elements which are included out here, and they are termed as rare earth elements. Rare earth elements. Next, actinoids or actinides. Actinoids or actinides. Okay, it is based on the name of the actinium. Actinium 89. Okay, the atomic number is 89 there for this element. Okay, and the elements which are present in this series are thorium, from thorium to the element that is lawrencium. Okay, and they all are termed as actinoids or actinides. The general electronic configuration here for the F block element is n-2 F1 to 14, n-1 D1 to 10, sorry, D0 to 2, D0 to 2, NS. This is the general electronic configuration for the F block element here. Okay. Now, what are some of the general characteristics here? Let's have a look on the general characteristics for the F block elements. So, number one, they are very heavy metals. They are, or we can term them as the most heavier metals. Okay. They generally have high melting and boiling point. They have high melting and boiling point. They exhibit variable oxidation state. They exhibit variable oxidation state as that of the transition elements. Oxidation states. Okay, next, they form colored ions. They formed colored ions. The ions of these particular elements, F block elements, are colored. Okay, they are forming colored ions. They have tendency. They also have the tendency to form complex compounds. They have the tendency to form complex compounds. Okay, actinides are radioactive elements. Actinoids are radioactive in nature. They are radioactive in nature, and many of the actinide are used in nanogram quantities. Okay, many of the actinide elements have been made only in nanogram quantities or even less by nuclear reactions, and their chemistry is not fully studied out there. Okay, many of elements in this series are formed in nanogram quantities. Okay, they are formed in nanogram quantities by nuclear reactions, by nuclear reactions, and they are termed as, they are called, and hence their chemistry is also not clear, है ना? Due to this reason only their chemistry is also not clear, and they are called as trans uranium elements. Trans uranium elements. Okay, so these are some of the different blocks which we have divided the periodic table in order to facilitate us to remember the properties of the different atoms or elements which are present in the periodic table. So for today we are ending the class here only, and in the next class we are going to discuss some of the more general properties related to the periodic table. So thank you for watching this video. We will continue more further in this chapter in the next video.